Hello and welcome back. Okay, so in the last video I showed these PCBs. Now these convert the pipeline here into permanent circuit. Now the plan is to get all of the ALU as well into PCB in the next few weeks, I hope, and also the new reset and clock circuit I'm working on. I'd like to try and get that onto PCB as well, because then all of this will be confined to over here and I'll have this side of the desk to start working on some additional bits of circuitry. Let's be bold. Right, so this is ALU operation. Going to need that. And these 5 lines are flags coming back from the ALU. We're going to want that. That's mem data going into the fetch unit. That's clock going into the pipeline. Reset. Now we're handling pipeline reset differently in the new version, so that's going to be a problem for testing. Now I don't need to remind you that this is one of the most important parts of the build. This is the pipeline. I actually started this project because I really wanted to build this and experiment with what I could make this do. So this set of breadboards has served me well. I think we may need to bring the clock circuit down for now, but let's solder this up and then worry about it. Okay, I want to do these backing boards first. Lots of through hole. Now I do need these turn pin female sockets in all the places for this, and I need to find some way of holding them. And for the boards that sit on top of here, I'm going to need the male version, so I may as well cut them now and use them to help me support this. Right, so I worked out a while ago that a stack of 3 boards holds some of these pins quite well. Now in theory this should drop on top. That's kind of cool. Didn't have a 5-pin one of these, so I'll use the right angle version and trim it later. Now I'm kind of working on the assumption that if I put the top plate on and then turn these over, it's going to work. So that was wishful thinking apparently. Let's do these a few at a time. I'm so smart enough to make these line up. This is all the pins I need for soldering the main boards. I can use a similar technique for this cluster. Let's get these done first though. And what I'm doing here is just tacking down one pin just so I can come at it from the other side and adjust it. This is going to work okay, but it really would have been a good idea to make the spacing between these exact multiple of 2.54 millimeters, because then I could have just used a piece of breadboard to do this. Okay, that's going to need a good clean down. That is a nice looking backplane. Now all we need is modules to go on here. Right, so this is the fetch unit PCB. Need to get the stencil set up for this. Okay, I think that's bang on. Before I get the solder paste out, I always sit down and make sure I've got exactly the components I need. Could do with a smaller spatula knife for this bit. I don't want to go over it all with a microscope. Right, so these are the 4:1 data selectors. So the primary job of these selectors is to determine if we are dispatching the byte that's coming in on memdata, dispatching a NOP because we don't have anything better to do, or dispatching the previously held instruction that has been cancelled for some reason. Now these are 1K resistor arrays. It actually gets pretty difficult to tell without looking at the microscope if I'm getting these the right way around. Okay, need to get the heat gun warmed up now. It still looks like magic when you get a bunch of components snap into place like that. That looks like a good board. This one's next. Okay, pipeline stage 1 is the most complicated of the pipeline stages. Very similar to pipeline stage 2, but it's just got this extra logic for killing off an instruction that's had a clash with the memory access. Now between takes, I did discover I've made a small mistake on this. You can probably spot it in hindsight if you go and look at my video where I designed the backplane. This row of pins here is 1/2 pin width offset down from where it should be. Now I have determined that bending it very slightly in the temporary backplane, I can just about make it work. I'll probably need to reflow or possibly refit this set of 5 pins when I switch to the final backplane. That's far from the worst mistake I've ever made. I've picked up the bit here that was starting to dry out. Good, I think we got that everywhere. These are red LEDs, so I need 1K resistor arrays. Turning resistor arrays over is not easy. The diagram on the silk screen has a notch. But these chips are actually marked just by the tiny little indentation in the spot. Now the entire left-hand side of all three pipeline stages can basically be fault of an 8-bit wide shift register. So the instructions enter at the bottom when they're fetched from memory and just move themselves through the pipeline stages, and then the control stages just turn that into activating lines. These larger value capacitors are practically square in their cross section. I wonder if the orientation matters. Now, these NAND gates are probably my favourite chips. Not because they make life easy, apart from when you just need a NAND gate, but because they're a universal gate, so you could actually make everything else with them. Almost looks to me as if that pin there doesn't have solder on it. I think it may be foolish to try and fight this. There is a small amount of solder there, and it's either enough or it's not. Now it's just the 16 control LEDs. I'm actually quite looking forward to having these. In the build at the moment I've just got 16 LEDs in a row, side by side. Having the demarcation here to tell us what they are is going to make it easier when I'm actually debugging stuff. Okay, so now we need sockets for the ROM chips. I did think about putting ZIF sockets here, but we're just not going to change them that often anymore. I think I may be overdue a new tip for this soldering iron. The diameter of these pins is very close to the diameter of the hole, so it doesn't wick as much soldering as I'm used to. Probably a good thing. This is the one I may have to redo later on once I replace this green background. I think that's it. You see the way these come in at a slight angle just to compensate for my bad positioning. That is coming on nicely. Need to go and get the parts for this one now. Okay, this is the one that was larger than the others. This was a mistake I made in the ordering, so it's not that big a deal. Now, this is exactly the same size as the Pipeline Stage 1, so it fits in there. Okay, I just discovered that the video feed wasn't recording, so missed a little bit of this. Now, if you can avoid tipping the LEDs out, they're a lot easier. I cut off one too few of those. Now I'm still a little bit worried about this one up here. Solder smudged around a bit. The surface tension does seem to be very good on those things. Now that does look like it may have solder bridged. Right, so this all seems to be good apart from these two arrays in the top left. So what can we do about that? There does seem to be an unnamed axiom in electronics of if in doubt, bathe it in flux. Don't want to jinx it, but that looked good. Okay, time for the through-hole bits. Get these out of here for a minute. Fortunately, all of these were in the right place. That, I think, is done. Let's see what it looks like altogether. I think it's time to get the main build out. Okay, let's see what we can do. Okay, we don't fully generate the correct reset signal for this. We really need to do a bit of work on the new clock circuit to generate that, but I think we can probably muddle our way through that. Mem data goes into the bottom of the fetch unit. Reset we still need in the pipeline, but we want... Now, in the breadboard version of the pipeline, we had a couple of bits of circuitry that affected the clock going into the register stack because we used that for the old style reset. Now I think we can probably just take that direct from the clock circuit up here. It does make me worry that there was a slight delay introduced on that and we're not reproducing that behavior. But that's why I put a separate clock input to the pipeline than the one that gets passed across to the register stack, because we could add that delay back in the clock circuit if we had to. All of these cross connections from the pipeline to bus control should get made with just this one board. ALU up. Now I did actually put the clock output in here because that's the AVA input to the ALU. So I can neaten this up slightly by putting that there. Okay, it's 5 flags from the ALU and we've got 8 lines here. Okay, so the rightmost one I put ground there. Then it's the 5 that come from the ALU. Next flag input is the PCRA flip-flop, which is generated in here, so this is just an output. Then we've got the reset input to the pipeline, which we have no way of generating. I'm just going to pull that low for now. So this is the clock input to the pipeline. Should be able to just take that from over here. Okay. Okay, if I reset now, we've got an empty pipeline, so we don't need to worry about the reset circuit difference. So instructions are progressing up the pipe fine. This program counter is asserted. It's really nice having these separate LEDs labelled. This looks like it's working. Okay, I just saw clear on the TTY. Be bold. Ha ha. This is awesome. It's working. I need to write some more interesting games at some point. I'm going to wait till I've got my proper display before I put too much work into that. I've got some work on debugging hardware before I want to write much more code as well. The as yet unused brake line coming out of here is going to be handy as well. That might be in the next video actually. Okay, so this is great. There was a lot of work went on here without me being able to test any of the progress, and the fact that this works is absolutely amazing. I'm going to start roughing out the next PCB here that's going to be the ALU and the new clock. I've also got some work on the new clock that will go down here in order to properly generate the reset signal, respond to the brake signal. Hopefully that will be the next video actually. This feels like the biggest single step forward in the circuitry in a single video, or at least the conversion to PCBs. I'm hoping this should be a lot more stable and reliable than the old pipeline. It was definitely developing some bad connections in some of the wires that made the whole processor a bit less stable. I really hope you found this interesting. This has been really rewarding for me. I can't thank everyone enough for the support they provide me in just kind of keeping going on this, because this has turned out to be a far longer project than I ever envisaged. Thanks a lot for watching. See you again soon. Goodbye.